Okay, well, good day. This is the electrical aspect of my parking lot. I'm going to be showing you the different functionality of the hardware and what the hardware does and how it's integrated with a parking lot. The next video will show you the implementation of these electronics and hardware in the parking lot. So as we see here, we have a breadboard. And these are the different wires that is attached to the breadboard. Now we're going to specifically um, zoom in on the OLED. This is a OLED display, and right now it's reading welcome, available parking, P1, P2, P3, P4, which are reserved parking, right? Which is 4 different lanes of reserved parking. So now we have 5 sensors. 4 of these sensors are used to signify when the designated parking spot is available or not available. When it's not available, it will no longer be shown on the display. So here we go. Zoom in on the display. So as you see, I just put my hands on parking number 3. So available would be parking 1, parking 2, and parking 4. Remove my hands. It's back to all available parking. Let's look at this sensor. Put my hands here. All right, so this is parking 2. As you see on the sensor, parking 2 isn't available. All right, now to find the other sensors.
Right here.
Okay, yeah, there's one here. Good. All right, this should be parking 4. As you can see, parking 4 isn't available when it detects that the car is at parking 4. Now, 1, 2, 3. This is the entrance. One more parking. Okay. And that's 4.
I thought the fourth one was near the entrance.
Now it's just hidden somewhere. Oh, let me just trace it from here. Okay. Okay, oh, that's why. The 2 of them is next to each other. Okay. So this is parking 1. All right. No, that's the entrance. So this is parking 1. Okay. So as you see, parking 1, when parking 1 is covered, it doesn't show that it's being available. Now, again, if I was to put, remove my hand, sorry. So all parking available on this remove. Now, 2 parking spaces are filled. I'll show you. So parking 1 and parking 3 are occupied. Therefore, only parking 2 and parking 4 is available. All right. There, I did parking 3 now. Parking 3 is filled. So only parking 4 is available. Parking 4 is over there. Right, over on the other side over there. Now parking 4 is there. It says proceed to the next level. Or proceed. I'm gonna write proceed to general parking. Okay. And you can let go. Everything got let go, and as you see. Now, when we're getting into the garage, right? As a car drives to the garage, look at me. As a car is driving to a garage, there is a gate that stops the car. When you enter in the garage, for that gate to open, you have to push a button. So one time you lean over to your window and you push the button. Well, there's a button for that. it will be this button right here. Right? I'm not gonna push it yet, but I'm just showing you the button. Now, when I push this button, this is called a servo motor. This servo motor is going to respond by opening the gate. The reason why I select a servo motor is because I can designate how high I want the gate to open and how I want the gate to close. So now I'm going to press the button and look what's going to happen. Put the camera on the motor. All right. Gate open, and you realize the speed that it's open, I program it to open at that gentle speed. So the car can go and come through, and it closes the gate when the car passes through, right? Because there's a certain amount of time a car will take to pass through a gate. Now, when we're exiting the parking lot, there is another gate. However, you don't have to push a button. Instead, the gate is going to open by itself. So we're going to use another hardware, another infrared sensor. Particularly, we're going to use this infrared sensor. Now we're going to use this infrared sensor. All right. This is the next gate, the exit gate. It's another servo motor. So now, when the car drives up to the gate with this infrared, it's going to detect the car at the gate. So look what happened. Again, strategically, I let the gate open and closes on its own because the car passed through. But anytime it detects a car, it will open back. The moment it's no longer detect a car, it give a certain amount of time, it will close back naturally. Finally,
Stop doing it.
It just detected
Yeah.
I was close. All right. Finally, now, in all parking,
Oh my God.
all parking lot, right? There is a situation where there may be an emergency. For instance, a fire. One of the cars, probably something happened and there's a fire, and let's say our alarm detects a smoke. Well, there needs to be a protocol, right? A protocol that states, listen, there is a fire. We need to stop all functionality and do this procedure. Until the fire is dealt with, this procedure should be done. Now, that's what we call an interrupt. On this with this microcontroller, there is a certain pin that is given, that is programmed into the microcontroller that will supersede all other functionality. And that pin on this board is pin 2. Can you show here? So it's the third pin where you see the white. This is pin 2. So this pin 2 will, whenever it's activated, will create an interrupt that will stop whatever functionality is going on in the parking lot and do the set of command that it needs to do for that emergency situation. Now, I'm going to show you. I'm going to show you the emergency situation. So in this emergency situation, infrared. All right, in this emergency situation, fire happened. One of the parking attendees see the fire, and what they're going to do is going to press the fire alarm button. When they press this fire alarm button, it's going to this first button right here. This first button. When they press that fire alarm button, it's going to let this gate open, and it's gonna constantly keeps it open, and it's going to make this light flash, and it's going to put a warning sign on the OLED indicating to the people that is going to enter into the parking lot, or anyone that can see it, that there's an emergency. And the red lights will be flashing to show that anyone else in the parking lot can see that there's an emergency situation. As you see, emergency, and right here, the gate open. You check that gate, remain closed. Reason why, because since it's a one-way into parking lot, you do not want cars coming into the emergency. You want it to remain closed. However, you want the exit to always be open so they can exit the parking lot. All right. And as you can see right here, the lights are flashing. That's indicating to people that there is an emergency. Now, as you can see, the LED, one more time, is flashing emergency. Zoom in more, please. As you can see, zoom is saying emergency. Now, fire truck come. I want to get this emergency situation off. Again, I'm going to use the interrupt, but the interrupt is going to reset everything and put it back into normal state. You can put that up. Okay.
No, just to show that it doesn't move. When
No, just... There we go. Back to the normal state that it was in. And just to show you again how this interrupt is so important, I'm going to put it back into emergency state. I'm going to try to use the sensor. This is a sensor that will automatically open and close the gate, the exit gate, right? Look, nothing is happening. These are the sensors too. It's sensing everything, but yet there's nothing happening because the system is in an emergency state, a volatile, as you will see in the programming. It's called volatile state. Okay. Yeah.
All right. I'm done.
Yeah, that's it. The resistors on that tend to be